All right, so we got some homework problems we're going to review today, some evens. And this is page 189 in your textbook, Stewart version 5, or Rev 5. And number 6 is x squared minus y squared equals 1. There is a distinct thing. It says use implicit differentiation. You know you have to because it's not a function. So you got to take the derivative of each of the three terms. And when you do that, we're going to actually skip the green and red step, but you got to think of the green and red step in your head. That the derivative of x squared is 2x dx. Derivative of negative y squared is negative 2y dy. Derivative of 1 is 0. But at the same time you're doing that, you're dividing everything by dx, the green. And when you do that, you actually are going to write the black as our goal as we practice. So when you see x squared, you're going to write 2x. When you see negative y squared, you're going to write negative 2y y prime. And derivative of 1 is still 0. And now this becomes an algebra problem. We're going to move the 2x to the other side. And then we're going to divide by the negative 2y. And you're going to get y prime solved by itself. I'm trying to scroll here, I'm having a little bit of difficulty. Is, whoops. The next one is y over x is the answer. Y prime is y over x. All right. We're going to start the next one. And again, you can try these and pause them. Again, the big thing you want to do is try to make the step from without dividing by dx. You want to jump to y primes. Okay, and I'll leave this off a little bit. Number 8 is looks to me like an x cubed.
Jade to Nicole Wyman to the office, please. Jade to Nicole Wyman to the office.
X squared minus 2xy plus y cubed equals c. All right. Now, if you want to pause and try it, you can. The big thing I see is that you're going to have a product rule here. You're going to have a derivative of x here. This will be a derivative of x term and a derivative of y term, and this is going to be a derivative of y term, and this is going to be 0. So you're going to have 4 terms on the left side equals 0. We're going to try to skip, and again, I'm going to do the red and green step, but we want to skip this step. We don't really want to write this if we don't have to. 2x dx, because we're going to divide by 2x. What we actually want to write for x squared is simply 2x. Next term over, I'll do the derivative with respect to x first. I usually do x first. So this is 2y dx, but like I said, we want to be dividing by dx as we go. We're trying to get to the point where we just write 2y. The next term in this product rule right here is derivative of y. Now this is where we get 2x dy, but we actually want to be writing 2x dy divided by dx is y prime. This one plus 3y squared dy, but again, we want to get used to dividing by dx each time we finish. And then we already agreed that derivative of c was 0. Everybody, calculus is over. The red's divided by the dx's. Like I said, we're doing this as we win. We really want to get used to, and again, we do it all sides, but 0 is still 0. We really want to get used to the idea that we are able to go from the blue to the black. Now, this becomes algebra. The rest of this is simply an exercise in algebra. We're going to have to move the 2y and the 2x to the other side. And I would probably do it this way. 2x y prime would be left. 3y squared y prime would be left. And I can see that if I write 2y minus 2x, I'm moving the two of them over. And now, and I'm thinking to myself, do I factor? I wouldn't bother because I see there's a 3 in this one. And I know that I'm not going to be able to cancel anything, so I'll just wait on factoring. I will, this is my shortcut. I think of this, and I can do this by just pulling out the y prime. So the y prime is 2y minus 2x over negative 2x plus 3y squared. There's a pretty high chance that it would be written positively like that on any multiple choice. And we have now found the derivative of that curve. And I'll call it a curve because it's not a function. All right? And again, the big thing to be practicing here is making the jump from the blue to the black. So 10, again, we'll try putting 10 up here, and I'm going to erase this. Give this a shot. And again, text this on page 188. Y to the 5th plus x squared y to the 3rd equals 1 plus x to the 4th y. Everybody, before you get going, and I'll pause it here for a second, one term, this is going to be 2 terms, this is 0, this is 2 terms, so you're going to have 3 terms equals 2 terms. This is a complicated derivative, and again, we do it by parts. We try to skip to, we try to do it divide by dx as we go. Give ourselves some space. Erase all this. All right, try to give myself some room. Because this is going to take some space, that's for sure. Again, I am actually going to skip the step this time. We're going to try to make the jump. So the first term, y to the 5th, is 5y to the 4th dy divided by dx, so it's y prime. I always do x first when I have a product rule, so I'm going to write 2x for your x squared, y cubed stays, dx, but we divide by it. Now I have to do the derivative of the other one, which is x squared times 3y squared dy divided by dx is y prime equals derivative of 1 is 0. I'm going to just skip it. So I literally come to this term because this is 0. 0 plus stuff is stuff. So the derivative of x to the 4th is 4x cubed y dx divided by dx, it's gone. And then derivative of y is just 1, so y prime. All right, and the challenge here now is here we are. This is it. We've done the derivative work. You literally just now have to solve for the y prime, and there are 3 of them, which makes it a little bit more complicated. All right, there are 3 of them. There's 1 here, 1 here, 1 here. So I'm going to send this term to the other side with the y prime. I'm going to send this term to the other side. So all the y primes are on one side. Everything else is on another. I'm starting to think that there's going to be some stuff to factor in this one when we're done. Then we're going to get to an answer that requires factoring. Again, my favorite trick is to put the parentheses in, put the y prime outside, and cancel it out. So my answer, and I always simplify it after I have an answer. I can see that x and y and 2 are common in the top. 2 is not common. There's y to the 4th, so x is not common, but I think every term in the bottom has a y. No, it doesn't. No, it doesn't. So there's the answer. There's the answer. All right, and we've just done the implicit differentiation of that. Now, again, the important reason we have to get used to just writing y prime is we are going to start taking the derivative of that derivative. And the derivative of y prime is 1 y prime prime. But over here, all these y turn into y primes, which is this rational expression of x and y. So that is the reason that we want to avoid writing dy, dx, dy, dx, and dy as we go. All right. So that's 3 problems. We'll make that one video. We'll try to pick up some more problems here in a moment.